Hi, I'm Dan Lachance. I've worked in various IT roles since the early 1990s, including as a technical trainer, as a programmer, a consultant, as well as an IT tech author and editor. I've held and still hold IT certifications related to Linux, Novell, Lotus, CompTIA A, and Microsoft. Some of my specialties over the years have included networking, IT security, cloud solutions, Linux management and configuration, and troubleshooting across a wide array of Microsoft products. There are many things to consider when managing and configuring basic security settings in the Microsoft Windows OS. Therefore, technicians must become well versed in configuring and enforcing workstation security settings to meet best practices for security. In this course, I'll show how to configure basic security settings, including firewalls, Windows Defender antivirus, users and groups, as well as operating system login options. I'll explore the difference between NTFS and share permissions, and also discuss file and folder attributes, as well as inheritance. We'll also discover features of the administrator and standard user accounts, and learn the fundamentals of user account control, or UAC. Lastly, I'll explore how to configure workstation security using features such as encryption, complex passwords, account management features, and by disabling AutoRun and AutoPlay features. This course can help you prepare for the CompTIA A+ certification exam 220-1102. In this demonstration, we're going to take a look at Windows Defender Antivirus here in Windows 10. Defender Antivirus is included as a part of Windows 10, and it's very effective at protecting the machine from potential malware threats. So the first thing we're going to do here in Windows 10 is open up the Start menu, and I'm going to search up the word virus. From in here, I'm going to choose Virus and Threat Protection. That takes me into the Windows Security dialog. Now, the first thing we'll see is a list of any current threats. We have a statement here that there are no current threats, and we also have a date and timestamp for the last scan, as well as the type of scan, a quick scan, as opposed to a thorough scan of every single file stored on disk. Now, we also have a quick scan button that we can click here to perform a quick scan. A quick scan will take a look at common folders where threats might be found, like the Downloads folder and so on. So in this case, our scan lasted 15 seconds, nothing was found. Now we can also click on Scan Options here to determine the types of scan that we want to be able to run, such as a full scan, check all files and all running programs, or a custom scan if we want to specify a certain location to look in. So specifically, a folder in the file system. And then the very important Microsoft Defender offline scan. Offline meaning that Windows won't be running. Well, how would that work? If you select a Microsoft Defender offline scan, it will restart the machine and then perform the scan when Windows isn't running. Sometimes system files are in use in Windows and you can't properly check or cleanse a machine from malware. Once you've selected the scan type, of course, you could then at the very bottom click the Scan Now button. You can also click Protection History to get a list of any potential problems that might have arisen in the past. So we don't have anything about any threats that were found, just some suggestions on securing the system. I'm going to click on Virus and Threat Protection once again over the left-hand navigator. We could also click Allowed Threats. What this means is anything that would have been treated as a threat that you have allowed to run in the machine will show up in this list. I'm going to go back to Virus and Threat Protection on the left, and then I'm going to go down under Virus and Threat Protection Settings and choose Manage Settings. Real-time protection is turned on, and this is important. Other than watching for malware in files, it'll also check running apps, any running processes. As I scroll down, I can also add or remove things like exclusions. These are folders where we might have activity at the file system level that normally triggers a false positive that malware was detected, when really perhaps it's just temporary files because we're installing an app or something along those lines. It does happen. I can also specify my notification settings in relation to any virus or threat issues. like scan results. Now, of course, if you've downloaded an individual file, you can even elect to right-click on that file and scan with Microsoft Defender. So here we've got one file scanned, lasted about a second, and there were no threats found. So if you've downloaded something, you just want to scan it quickly, you can also opt to do something like that. From the Start menu, I'm going to search for the word Update. And I'm going to choose View Your Update History because one of the categories of updates, each category here can be expanded or it can be collapsed. One of them is definition updates. And these are definition updates for Microsoft Defender antivirus. It's part of the Windows Update mechanism. So we have a history here of any new Defender updates that were applied. Of course, we could also at any point in time run a manual check for any new updates. So from my Start menu, if I search for Update and then choose Check for Updates, so I can go ahead and do that. That will also include any Windows Defender definition updates. And it's important to make sure that those are the latest version to make sure we have the best protection from malware. In this demonstration, I'm going to implement some firewall settings using the built-in Windows 10 Windows Defender firewall. So first of all, what we're really talking about here is a firewall that can take a look at various aspects of files or incoming or outgoing network traffic to make a determination as to whether that should be allowed or whether it should be blocked. So to get started here in Windows 10, I'm going to open up my menu and I'm going to search for the word Firewall. From here, I'm going to choose Windows Defender Firewall. Now, in the interface, we have different categories of networks and whether or not we are connected and whether or not the firewall is active for those network connections, like private networks. Private networks, I am not connected, but guest or public networks, I am connected, and the green shield icon implies that the firewall is turned on for those network connections. And for guest or public networks, incoming connections, we have a statement that says block all connections to apps that are not on the list of allowed apps. So there are various ways that this can be configured. Over on the left, I can choose to turn Windows Defender on or off. This is where it's determined that it's on or off for public guest networks or private networks. And here we also, for each network profile, have options for notifications, if an app is blocked, whether it's for a private network or a public type of network. Of course, you could also turn off Windows Defender, but we're not going to do that for any of our network connections. And you could also choose to block all incoming connections, regardless of what you've configured as being allowed. So there are quite a few things that we can do at that level. Just going to click back. I can also choose Change Notification. I could also choose Allow an App or Feature through Windows Defender Firewall. When I click that, I have a list of allowed apps and features, and then of course I have the network profile column at the top and a check mark as to whether the selected entry, the app, is allowed or not. So for example, if I want to enable remote desktop, all of them, I can determine which network this should be available on. Maybe I want to allow Windows Remote Desktop not on public networks, but rather only on private networks. So I could turn on the check mark for that. I could also click Allow Another App by clicking Browse and looking for the executable program for a specific app that might not already be shown in the list. In other words, whatever that app does in terms of network traffic would be allowed. You have to be very careful because if you're dealing with a malicious app, you're telling it that it can do whatever it wants. So we want to be careful with that. I'm just going to go back here in the upper left and I'm going to choose Advanced Settings. This is where it opens up a new window where I can view all of my inbound rules, what kind of traffic is allowed into this device, as well as all of my outbound rules. Now, we know that it would be allowed in to the machine or out from the machine if it's a green circle with the check mark. You can right-click on any one of these rules and choose to enable it, which gives you the green circle with the white check mark, or you can right-click and disable it, which doesn't provide any icon at all. You can also right-click on inbound or outbound firewall rules and filter, for example, by profile, such as for private networks or by state, maybe only enabled, or by certain group type, such as mail and calendar firewall rules, and so on. However, I'm just going to right-click on inbound rules again and clear all filters. You can also right-click on in or outbound rules and choose to make a new rule. For example, I can create a firewall rule based on a program or a port number, so TCP or UDP port number, which identifies a network service. We can choose from the list of predefined items, such as file and print sharing or iSCSI service for network access to storage, remote desktop, and so on. Or we could build a completely custom rule, which I'll do here. What I want to do is make sure that I am blocking ping traffic. So to do that, I'll make a custom rule. I'll click Next. It's not specific to a program or a specific service, so I'll leave it on all programs. I'll go to Next. For the protocol type, it says any. Well, I know that when we ping in an IPv4 environment, that uses the Internet Control Message Protocol, or ICMP v4. But then I'm going to go down and click the Customize button next to Internet Control Message Protocol, ICMP settings, because here is where I can specify, I want to make sure that I block echo request. When you ping a host over the network, you are sending an echo request. And normally it will respond with an echo reply, so you know that the ping is receiving a response. You know that the device is up and running and available over the network. I want to block it. So I'm going to say echo request. I'm going to click OK, next. Does it apply to any specific IP addresses or any type of echo request ICMP traffic? I'm not going to specify IP, so I'm just going to go ahead and click next. And I want to block the connection. You could allow the connection or allow it if it's secured, such as through IPsec, but I'm going to leave it on block connection, and I'll click next. And I want it applied to all network profiles. Next again, and I'm going to call it block inbound ping. Then I'll click finish. So if I go back to my inbound rules in Windows Defender, then I've got my block inbound ping, and we've got a no entry type of icon for it. So the rule is enabled, but it doesn't allow traffic, it blocks traffic. You can do the same type of thing to create additional inbound rules or outbound rules for traffic stemming from this machine going out to the network. Connection security rules over in the left-hand navigator and monitoring are only applicable if you're using IPsec policies to secure network communications. Finally, I could right-click on Windows Defender Firewall in the upper left of the navigator and export the firewall policy and perhaps import it to another computer instead of creating all the rules individually. Now, if these machines are all joined to an Active Directory domain, you can configure Windows firewall rules in group policy instead of going to each machine to configure machines that have the same firewall needs. You can manage local users and groups on a Windows 10 computer, just like you can also do that on a Windows Server operating system, especially when it's not joined to an Active Directory domain. An Active Directory domain provides a centralized network database that's replicated among domain controller servers, and that database would contain things like users and groups. But here the focus is local users and groups. So here in Windows 10, I'm going to open up my Start menu, and I'm going to search for Computer because I want to go into the Computer Management app. The reason I want to go there is because that's where I can manipulate local users and groups. Here we've got local users and groups on the left. I'll drill down under that, and I'll choose Users. So we have a number of user accounts here. There are some default users like the administrator account, the guest account. Now, the idea is that the guest account lets people sign into the computer, but they won't be able to change any settings. Certainly, they won't be able to install apps or printer drivers. They won't be able to install any other user files that are stored in their own user profiles on this machine. When I say their own user profiles, if we look at the file system of a Windows 10 computer, by default, it wants to install on drive C. And under drive C, there is a users folder under which there will be a subfolder for each individual account on the machine, like C Blackwell. If we go back and look at computer management, indeed we have a C Blackwell file. Of course, the administrator account, if it were enabled, and it's not enabled because there's a little arrow pointing down on a lot of these accounts other than C Blackwell. But the administrator account can do anything on the machine, but it's disabled by default. We could right-click on it and go into the properties of that account. Currently, the account is disabled. Well, if we want to enable the default administrator account, we could go ahead and remove that check mark. The account's now enabled. There's no longer a little tiny icon with an arrow pointing down because it's no longer disabled. Of course, we can also right-click on an existing user account and reset the password. And of course, I could create new user accounts. I could right-click here and create a new user. Let's say user J Hill, full name of Jen Hill, and we could also specify and confirm a password for that account. The user will have to change the password at next logon unless we remove that check mark. I'm just going to remove that check mark for this example. I'll click create, and after a moment, user Jen Hill shows up in the background. We've also got a number of built-in groups. Of course, members of the administrators group are not limited to what they can do on this particular machine. Members of the power users built-in group have a lot of permissions, except they can't do everything administrators can. They can't access other users' data files in their user profile directories, which we talked about. And of course, they can't add themselves as members of the administrators group. So if I were to go into the power users group, I could click add for members, and I could specify J Hill. It's going to look for that account on the local desktop machine. That's the default computer name here. OK and OK. So user J Hill now is a member of the power users group. I can also verify this from the perspective of that individual user account by opening up the properties when I double click on the user and going to member of, and indeed, she is a member of power users. However, J Hill only exists on this individual computer. And so J Hill could not go to other computers and sign in unless we created an account for her on each of those computers as well. Now I've switched over to a Windows server that is joined to an Active Directory domain, just so we can quickly examine how it's a little bit different when we create an Active Directory user account. So from the Start menu on this server, I'm going to choose Windows Administrative Tools, and I'm going to choose Active Directory Users and Computers. You don't necessarily have to be at a server to run this management tool. You can run it from a workstation that is joined to the domain, for example. At any rate, Active Directory uses organizational units, or I should say it can if you create them. I've created Eastern Region, under which I've created an organizational unit or an OU for computers and users. You can do the same type of thing over and over and over for different OUs to organize your user accounts. Not only that, you can also apply group policy settings to specific OUs. So that's another good, compelling reason to create OUs. At any rate, I'm going to create a user in HQ headquarters. I'm going to create Jen Hill here in Active Directory. I'm going to right-click on HQ, going to choose New User. And again, I'll fill out the blanks. So I'm going to go ahead and specify Jen Hill, and the user login name will be J Hill, and it's going to use an @ symbol with the name of my Active Directory domain, which in this case is quick24x7.local. That's the full principal user login name. I'll click Next, and I'll specify and confirm a password for her account. I'll leave the user must change password at next logon option enabled. We've got other options like disabling the account, preventing the user from changing the password, whatever makes sense for the type of account. I'm going to leave that as it is and just go through and create the user. And if Jen Hill happens to be a help desk technician, I already have a help desk group here. So I could actually select user Jen Hill, click the Add User to Group button up at the top, and specify that I want her to be a member of the help desk group. I'll type in help, check names. This time it's checking in the domain as opposed to an individual computer, and OK. And I've added the user to the group. Now, the difference here in this particular last example is Jen Hill would be able to sign in with these Active Directory credentials from any computer joined to this Active Directory domain. Her account does not have to exist locally on each of those domain joined computers. In this demonstration, we're going to explore sign-in options available on a smartphone. Now, the phone I'm using specifically is an Android-based smartphone, but the same type of options are available on a Windows phone and on an iPhone. It's really all the same type of concept. So let's get started. Here in my Android phone, I'm going to go down to the settings and tap that icon. And why don't we start perhaps by going into privacy? Here in privacy, one of the things that is relevant is the option to show passwords, which is turned on. And it states underneath that display characters briefly as you type. Now, for the utmost in security, we can disable that. The next option underneath that is whether we want to show notifications on the screen even if the device is locked. Now, notifications might reveal sensitive data in some cases, especially if it's a notification about a private message, maybe through SMS text or through email. So I'll cancel out of that. And I'll go back. Then we're going to go down into security. In the security section, we have a number of options at the top, such as Google Play Protect, which is essentially a suspicious app scanner, or at least that's what it's looking for. If it detects abnormal behavior for an app, it will notify you about that. So behavior analysis. If I go back and go underneath security update, it'll show me if we are up to date. In this case, I've got Android version 11. It's telling me I'm using the latest software. And I also have the very detailed current software version number and any security patch dates for any patches that were applied. I'll go back. I can also enable Find My Device, which is currently off. When I turn on Find My Device, it allows me to go to the Google website in order to try to find my device if it's lost or stolen. However, I'm going to turn that off. And I'm going to go back. Now, down under device security, we have a number of login options for the phone, such as a screen lock with a PIN. That's currently what it's set for. I can choose how to lock the screen. I could set it to none. I could set it to swipe. Now, when I select something, it says, do you want to remove the current setting, which is a PIN? I don't want to do that, so I'll cancel. I could go set a pattern. Of course, it tells me you need to have at least 4 dots connected for a pattern to be used, but I'll go back out of that. We know that a PIN is currently set as the screen lock option, but we could also opt to set a password to unlock the screen. Now I'm going to go all the way back to our device security options, where we'll now get into the biometric stuff, physical attributes about your body, like a unique fingerprint. And then I'll tap Setup. Okay, so at this point, it wants me to put my finger on the sensor, which is normally the power button. So I'm going to go ahead and do that. Each time I do that, it keeps adding a blue outline around a circle. So it needs to have multiple samples with my finger at slightly varying positions in order to do this correctly. Once I've reached the end, it'll state at the top that the fingerprint has been added. I can choose to add another one, but I don't need an additional fingerprint. I'm the only one using this device, so I'll tap on Done. And now fingerprint 1 is shown at the top. I could tap the trash can icon on the right to remove it to add another one, but I'm not going to do that. Down below, we've got an option labeled Touch to Unlock. In other words, I just have to touch my finger on the power button gently. It'll scan my fingerprint, and if it's a match, it will unlock the device. So I'm going to go back, because the next biometric sign-in option is Face Unlock, facial recognition. And then I'll tap Setup. Now, it does give me a little note here about the fact that face matching is not considered to be as secure as a pattern, PIN, or a password because it's looking at facial characteristics. Therefore, somebody that looks like you potentially might be able to unlock the phone. But it also does say that the data used to recognize your face data, is kept private on the phone. It's not sent anywhere else. So I'm going to go ahead and tap Next so it can take my picture. Okay, so now that it's got a scan of my face, I can choose a couple of other options, such as Lift to Unlock. In other words, I can just raise the phone and then look at it to unlock it, and the facial recognition will let me in. I'm going to go ahead and tap Next, and got it. And then I'll tap Smart Lock. So from here, with on-body detection, it'll detect if I'm moving and keep the phone unlocked if it's already unlocked. If I go to Trusted Places, I can add trusted places where once my device is unlocked, it will remain unlocked, such as on a large property. I can also go to Trusted Devices so that if I have another device in close proximity, like perhaps a car with Bluetooth or a smartwatch, once the device is unlocked, it will stay unlocked while it's in close proximity. So those are some convenient options. And there you have it. We have a number of ways then to secure signing in to a smartphone. The way we've done it was on an individual phone. You can imagine how much work that would be if you've got hundreds of phones to support. And that's why a centralized mobile device management or MDM solution makes a lot of sense for scalability in the enterprise. There are many aspects to Windows file system security, whether we're talking about a Windows client operating system or a Windows Server operating system. Security really works in the same way. The only exception would be with some editions of the Windows client operating system, like Windows 10 Home Edition versus Windows 10 Enterprise Edition. An example of which is that you don't have the option of working with encrypting file system or BitLocker with Windows 10 Home Edition. So we're really going to talk about permissions at the NTFS and shared folder levels, as well as encryption using built-in mechanisms in Windows. So with shared folder permissions, we're talking about having a folder on a Windows machine that's shared out over the network to potentially allow others to access the contents within the shared folder. Can't share a file, but you can share a folder that has one or more files in it. So that means that the permissions that we apply to the shared folder will apply when the folder is accessed over the network, such as through a UNC path, a Universal Naming Convention path. Shared folder permissions do not have any effect when they are being accessed locally. In other words, when we sign in locally to a device and open up that folder locally, shared folder permissions are not applicable. Now, shared folder permissions include full control, change, and read. That's it. It doesn't get any more granular than that at the shared folder permission level. Then we have NTFS, or New Technology File System, permissions. That's assuming that you formatted a disk partition on the Windows host using NTFS. Because if you formatted it with, let's say, FAT32, you wouldn't have NTFS permissions available. So NTFS permissions then require an NTFS formatted partition, and the permissions that are set will apply locally and when accessed over the network through a shared folder. Now, we say here on the server with the understanding that a Windows client sharing a folder over the network is considered to be a server, in quotes, hosting that shared folder. So the permissions that we set apply to folders in the file system and also to files. Now compare that with shared folder permissions, which can only be set for the folder and then flow down and are inherited by files in that folder. With NTFS, folder permissions are also inherited by child objects, although you could set specific permissions on individual child items, in other words, files. The NTFS has more specific permissions than shared folders. At the NTFS folder level, we've got full control, modify, read and execute, list folder contents if it's a folder, read, write, or we could have a combination of special permissions. Now you might look at this list and say, well, wait a minute, what's the difference between having the ability to modify a file versus write to it? The difference really is that modify will also allow the deletion of the file. Write won't, although it will allow, of course, writing to the file and saving the changes. Now here's the thing, when you combine shared folder permissions with NTFS permissions, the most restrictive takes precedence. So we might have full control permissions at the shared folder level, but when someone comes in over the network, they would get full control to everything in that folder unless we had lesser permissions at the NTFS file system level for that folder or files within it. If all we had was read and execute, then even though you've got full control at the shared folder level, read and execute would take precedence. It's a lesser permission set. And that's what happens when you combine share and NTFS permissions. But Windows file system security isn't only about shared folder permissions and NTFS permissions, it's also about encrypting file system, or EFS. In the GUI, so within Windows, you could right-click on a file or a folder, and if you go into the advanced attributes, you could choose whether or not you want to encrypt contents to secure the data. What you're doing here is encrypting it using EFS, encrypting file system, which is built into Windows, except for editions like we've mentioned, Windows 10 Home Edition, And the encryption here occurs based on the signed in user. It's tied to the user account, so it's encrypted for the user. You can also do this at the command line using the cipher command, which is also built into Windows. The first example of a command here is cipher C:\projects, and it shows that the projects folder is unencrypted with a capital U. So if we run cipher C:\projects/E to encrypt, it says it's encrypting files in that projects folder. /D would be for decrypt, of course. Now again, remember that using EFS encryption is tied to the currently logged on user. Now, if you have PKI certificates for other users available on this machine, using the GUI or the cipher command line tool, you could also add others to have the ability to decrypt files and folders encrypted with EFS. Now compare that with Microsoft BitLocker, where EFS allows you to cherry pick individual folders or files that should be encrypted. BitLocker is full disk volume encryption. You can't specify individual files or anything like that. So EFS can encrypt individual files and folders. BitLocker doesn't. EFS is tied to a specific user account. BitLocker is tied to a specific machine. Actually, by default, BitLocker is set to use TPM, Trusted Platform Module. A TPM is a specialized chip, either burned into the motherboard or it could be an add-on chip that you could add after the fact that is used for cryptographic operations, such as verifying startup boot integrity to make sure it hasn't been changed in an unauthorized way, and also to store BitLocker encryption keys. So whether or not you use TPM depends on how you configure group policy. If you don't have a TPM chip, you can still use BitLocker. You might even use BitLocker where you enter a startup pin when either the machine boots up, if it's the boot disk that's encrypted with BitLocker, or a startup pin or a password for additional data disks in the machine that you've encrypted with BitLocker. You might even use a smart card to authenticate and unlock a BitLocker encrypted drive. So there are plenty of options available. So there you have it. We can secure the file system on a Windows host using share permissions, NTFS permissions, EFS encryption, or BitLocker encryption. Supporting Windows stations means having an understanding of how the various user accounts work in a Windows environment. Specifically, our focus here will be on administrator versus standard user accounts in Windows. So here I'm using Windows 10. What I'm going to do is open up the Start menu and I'm going to search for User. Because what I want to do is get into the Add, Edit, or Remove Other Users section of the system settings. There are various interfaces that allow us to work with this. First of all, we have the Family and Other Users option, so under Your Family, where we could sign in with a Microsoft account. Down under Other Users, I already have a local account called Jen Hill, where I could sign in locally on this computer as that user. But we can also add someone else to this PC. So when I click Add Someone Else to this PC, it wants me to sign in with a Microsoft account. However, what I could do here is choose I don't have this person's sign-in information. And after that, I could also choose add a user without a Microsoft account, because maybe all I want to do is add a local account and not have an email address for a Microsoft account set up and all of that. So I'll choose add a user without a Microsoft account. Now I'm going to add a user called M Bishop, and I will enter and re-enter a secure password for this account. And then I'll specify 3 security questions and answers. After I've gone through that, I will now have a new local account by the name of M Bishop. Let's just go ahead and sign out of this computer and sign in with our newly created M Bishop account. So from the Start menu, I'm going to click the little person icon, and I'm going to choose M Bishop, where I'm prompted for the password for that account. Okay, so I'm going to specify the password and sign in. Now this is the first time this person has signed in, so it's going to go through some of the standard motions that Windows 10 does to initialize a user profile directory on the hard drive to store personal documents. You're then asked a host of questions related to whether you want location data turned on. I'm going to turn that off. I'm just going to go ahead and accept that beyond that. And I'm now signed in as user M. Bishop. However, this account will have limited access. This is a standard user. You don't get an administrative account by default when you add a new username. You get a standard user, which means they are limited in what they can do. They can use apps, but they can't install apps. They can't make a lot of system changes other than personal preferences in the Windows environment. So I'm going to go back to the Start menu. And once again, I'll click on the person icon. And again, I can switch between different people, or I could actually sign out from this account if I'm finished with it, which I will do. And I'm going to sign in with the administrator account. So I'll go ahead and choose Sign In. And again, if you've never signed in with that account, it'll initialize it the same way it did for our user M. Bishop. And again, I'll just accept the privacy settings. So I'm now signed in with the administrator account. Now, if I were to search my Start menu for Computer and choose Computer Management, I'm just going to right-click and go into the taskbar settings at the bottom and hide the taskbar in desktop mode. Now back to computer management here, if I go to local users and groups and go to users, here we have a number of user accounts like administrator, who I am signed in as. I can verify that in many ways, such as at the command prompt by typing who am I. I'm logged in as the administrator. We've got C. Blackwell, J. Hill, M. Bishop, who we've just created. If I were to open up the M. Bishop account and go to the Member Of tab, that person, by default, was added as a member of the users group, so very limited access. Whereas the administrator account, if I go to Member Of, is a member of the administrators group. Now, because I'm signed in as the administrator, I could change membership in the administrators group for any other standard or regular users. But take note that the administrator account is working here because it's enabled. In Windows 10, the administrator account is disabled by default. So I could right-click and go into Properties. Could also double-click on it and go into Properties. It doesn't really matter. But we could disable any account to prevent it from being used to sign in. And that's what the administrator account is in Windows 10. So naturally, I had already enabled it to allow me to log on with that administrative account. The other thing to think about when running scripts or apps or installers on a machine is running it with elevated privileges. For example, if I go into the Start menu and if I were to right-click on Microsoft Edge, I could choose More, Run as Administrator. And of course, it would run it with elevated privileges. Now, depending on how your machine is configured, you might even have to do that if you're signed in as the administrator. Because from the Start menu, there is this User Account Control or UAC thing, where you can drag the slider up or down if you want to increase or decrease the UAC settings. The idea, as it states here, is User Account Control is an option that helps prevent apps, so programs, from making changes to your computer without your knowledge or consent. Now, from the Start menu, if I were to go back, let's say in as M. Bishop, so I'll enter the password once again for that account on this machine. And as M. Bishop, if I were to go into the Start menu, right-click Microsoft Edge, choose More, Run as Administrator, it requires me to have knowledge of the administrator password if I'm not already signed in as the administrator account. So it's important then for technicians to have this kind of understanding when it comes to dealing with different types of user accounts on a Windows machine. BitLocker is a Microsoft software solution that is designed for the protection of data at rest, whereas BitLocker To Go extends that just a bit further and applies it to removable storage media. So we're going to focus on that in this case, removable storage media. I'm going to start here in Windows 10 by first going to Windows Explorer. I want to look at the file system specifically to point out that I've got a USB drive plugged in. It's showing up here as drive letter E, and it looks like we've got a couple of PDFs and so on that. So I want to protect that USB drive with BitLocker. Now I could right-click on the USB drive here in the Windows File Explorer tool, and I could turn on BitLocker. Or we could go to the Start menu and search for BitLocker and choose the Manage BitLocker option. Now, this is more comprehensive in that we see BitLocker on a more global scale, so to speak, for this machine. We see that drive C, BitLocker is off, although we could turn BitLocker on. If I were to do that, it pops up a message that says we can't do this because we haven't detected the Trusted Platform Module, TPM. Now, you don't necessarily need Trusted Platform Module, and it's telling us that we can go into group policy and enable these listed options if we want to be able to encrypt drive C using BitLocker, but without TPM hardware. So I'll cancel out of that. We then have the option of going down under removable data drives where it's labeled as BitLocker to go, and I've got drive E showing up here as BitLocker being off. So I can click on that and then choose turn on BitLocker. We can choose to either use a smart card to unlock or decrypt the drive or a password. Well, I don't have a smart card reader in this machine, so I'm going to have to use a password. So I'll specify and confirm the password here. Once I've done that, I can click Next, and it asks me where I want to back up my recovery key. The recovery key is important if you forget the password to unlock that BitLocker to go encrypted drive. So I could choose to save to my Microsoft account, save to a file, or print it. So I'm going to choose Save to a File, and I'll just save it with the default file name in the Documents folder on this machine, and I'll choose Next. I'm going to use the default option to encrypt used disk space only, which is quicker than encrypting all storage allocation units on the disk. Okay, so I'll click Next, and I want to use compatible mode, which allows me to use this removable thumb drive on older Windows machines that support BitLocker. So I want that option. So compatible mode it is. And I'll click Next, and I'll choose Start Encrypting. So it's not a very big thumb drive. There's not much on it, so it won't take long before the BitLocker drive encryption for that USB thumb drive is completed. Okay, encryption of E is now complete. So we now have a number of options, such as backing up the recovery key, changing the password for that removable media, removing the password, adding a smart card perhaps after the fact, turning on auto unlock, or turning off BitLocker in its entirety. If we go into the file system into Windows Explorer, it's hard to tell, but there's a tiny padlock icon on USB drive E. So we can still see the contents of it because it's currently decrypted. But let me go ahead and eject it. Okay, so the hardware is not showing up. So let's see what happens when we insert that USB drive. So when we do that, we get a BitLocker drive encryption message. Basically, we've got this encrypted drive. It's got a little padlock icon. If I click on it here in Windows Explorer, it says, well, wait a moment. You need to enter a password to unlock this drive. If I click More Options, I could also choose to enter the recovery key, which I had saved, if I forgot the password. But I do remember the password. So I'm going to go ahead and enter the password. Notice we can also choose to automatically unlock the BitLocker encrypted drive on this particular machine. I'm not going to do that. So I've entered the password. I'll click Unlock. Once I've done that, the drive will have been decrypted, and when I click on it, I can now see the contents of that BitLocker protected drive. But that's on Windows 10, specifically Enterprise Edition. What about a Windows server? How does BitLocker work? Well, the first thing that has to be done is we need to check that the BitLocker feature is installed. So here on my Windows server, I can do that in the GUI. That's one way to do it, by going into the Server Manager. Here in the Server Manager, I can go to Add Roles and Features and keep going through the wizard till such point I hit the Select Features screen, where I can determine whether or not BitLocker drive encryption is installed. Here it's showing as already having been installed. From PowerShell, if I want to enter in some commands here on my Windows host, I could also run git-windows feature and use wildcards around BitLocker. And when I press enter, BitLocker drive encryption shows up here with an X in the box indicating that, in fact, the BitLocker feature is installed. And so at this point, it's going to be very similar to what we saw in the Windows 10 client operating system, where we can go to the Start menu, look for BitLocker, there's Manage BitLocker, and we have the same type of options where we can work with BitLocker on the operating system or the boot drive, any additional fixed data drives that might be present, and also removable data drives. And keep in mind that the big benefit of BitLocker is protection of data at rest, especially when the machine is off when it comes to operating system drives. For BitLocker to go removable drives until you either enter a smart card or enter in the correct password, it's still encrypted. If someone were to steal server hard disks encrypted with BitLocker, the chances of them decrypting the contents of that drive are slim to none. Ever since Windows 2000, Microsoft has included encrypting file system or EFS capabilities into some editions of its operating systems. Notable exclusions in the Windows 10 realm would include Windows 10 Home Edition. As an example, here I am using Windows 10 Home Edition, and if I were to right-click on a file and go into Properties, and then go into the Advanced button where I would normally go to encrypt or decrypt an EFS encrypted file, I don't even have the option of enabling encryption. I can choose to compress, but I can't encrypt. And if I were to check the properties of the disk where that file resides, in this case drive C, so if I were to right-click on it, let's say, and go down to Properties, it is indeed formatted as NTFS. Now, you need NTFS for EFS. So the reason that this is not an option is because I'm using Home Edition. So from the Start menu, if I search for System Information and pop up the System Information tool, indeed, I'm running Microsoft Windows 10 Home Edition. So therefore, encrypting file system is not an option. So why don't we take a look then at Windows 10 Enterprise Edition, where encrypting file system is an option. Now, of course, EFS is always an option on the Windows Server class operating systems if you install the feature. Okay, so here in Windows 10 Enterprise Edition, let's go into the file system. I'm going to go into Windows Explorer, and I'm going to go to this PC drive C, where I've got a folder called Projects, and I have a number of files. Now, what I want to do is, first of all, verify that drive C is formatted as NTFS. So I'll right-click on C, Properties, indeed, it's NTFS. Okay, so if I were to right-click on one of these project files here and go to Properties, and then Advanced, I have the option to either compress to save disk space or encrypt, but not both. So if I choose to encrypt contents to secure data, I am enabling EFS encryption for that individual file. For now, notice the Details button is grayed out and unavailable. We'll come back in a moment and check that. Okay, so I'm just going to click OK and OK. I'm asked, would you like to encrypt the file and its parent folder? Now, if I choose to also encrypt the parent folder, which in this case is called Projects, it means any files that are dropped in here, created or copied, will be automatically encrypted. Or I could choose to encrypt the file only, which I'm going to do, and I could say always encrypt only the file, that kind of thing. Encrypt the file only. Okay. So the file is encrypted, and I'm prompted to back up my file encryption key. Now, that'll happen the first time that you encrypt something with EFS. So I can back up my file encryption certificate. So this is a certificate that gets generated if it wasn't already in existence, and a key. Now, administrators can configure certificates ahead of time to be used for this purpose. Otherwise, it's auto-generated. We can choose to back it up now, later, or never back up. Well, of course, we should always back up this type of information so that we can, in this particular case, decrypt EFS encrypted files. So I'm going to choose Backup Now. So that takes me into the certificate export wizard. I'll just go through Next, and I'm going to specify that I do want to add a password to this because I'm going to be exporting a private key. So I'll confirm a password, and then I'll click Next. It wants me to specify a file name where I want to export this. So how about I put it in Documents, and I'll call it EFS cert key, and this is for a user that's currently logged in by the name of C. Blackwell. Okay, perfect. Save. All right, so we've backed that up. All is good. While we're on the topic of certificates, if I were to go into, let's say, a command prompt and run MMC, Microsoft Management Console, I could go to the File menu add, remove snap-ins, certificates, add for the user account that I'm currently logged in as, and finish my way through there. So the point is this: if I drill down on the left under certificates and go under personal certificates, we've got a certificate issued to user C. Blackwell. That's who I'm currently logged in as. Issued by C. Blackwell, so issued to myself by myself. I've got an expiration date in the future, and the intended purposes of this certificate are, of course, encrypting file system. So that's the certificate that was generated automatically when I first encrypted a file with EFS a few moments ago. So I'm going to close that out. I don't need to save any of that stuff. I'll close the command prompt. Now, the file is encrypted here, project A. We can determine that by looking at the icon. There's a tiny yellow padlock. It's quite small, but also if I right-click on the file and go back into Properties under Advanced, the check mark for Encrypt Contents of Secure Data is enabled. Here's the Details button, which is available now. The file is already encrypted, and I've got myself listed up above as a person who can access this file. We could also click Add, and we could view certificates from other users. We'd have to have their certificates and public keys in order to add them here. This would allow you to use EFS to protect files by encrypting them, but allow multiple people the ability to decrypt the file. Maybe you've got a group of people working on a project that need access to the same file. That file has sensitive data, so it could be useful there. We also will have any recovery certificates for recovery agents, if configured, shown here. Recovery agents, as the name implies, have the ability to decrypt or recover encrypted files for users if they, for some reason, can't. Maybe they forgot their user account password, the user account is corrupted, needs to be recreated, that type of thing. So I'm going to go ahead and cancel that, cancel my way out of here. Now, if I were to create a new file, let's say I right-click and make a new text document called project_D. The question is, will it be encrypted or not? The answer is no, it's not encrypted, because when we encrypted project A, the file, we elected to encrypt the file only and not the entire folder. Let's just go back up to the projects folder here. If I were to right-click on that folder and go into Properties, Advanced, and if I were to choose to encrypt the folder, so OK, apply changes to this folder only, which means any files in that folder currently not encrypted will remain unencrypted, or just encrypt everything right now and even new stuff that gets added. Why don't we say everything? I want to encrypt all of my project files. Okay. So now if I go into projects, everything is encrypted. And if I were to build a new file, let's say right-click New Text Document, or copy it here, it doesn't really matter. Let's call it Project E. The file is encrypted. This is evidenced by the yellow padlock icon. And also, I could also verify that by right-clicking on the file, Properties, Advanced, and sure enough, checkmark for encrypt is turned on. Now, don't forget that you can always manage EFS encryption at the command prompt. So if I were to, for example, change directory to /projects, clear the screen and just type in cipher, it'll show me the fact that new files added to this directory will be encrypted, and that each of the project files themselves are encrypted as evidenced with the capital E. If I were to say cipher/D, let's say just one file, project E.txt, that one file will be decrypted. Let's clear the screen and just run cipher. Indeed, project E now has a capital U, which implies the file is no longer encrypted, it's unencrypted. So you can work with the EFS file encryption then using the GUI or using the cipher command line tool. Security and data privacy are enormous topics when it comes to managing IT environments. So let's talk about encryption of data at rest. We're talking about scrambling or encrypting data that is stored somewhere, whether on premises, whether in the cloud, tape backups, USB thumb drives, standard hard drive, smartphone. It doesn't matter. Encryption of data at rest always provides data confidentiality. That means that if you do not have the proper decryption key, you cannot reveal the original data. So you cannot make sense of it. Now we're talking about encryption of data at rest, data that's stored somewhere. There's also encryption of network transmissions. In other words, encryption of data in transit, which is often used for websites, for example, over HTTPS. That would require a PKI certificate on the server side in that example. Let's start by talking about Windows Encrypting File System, or EFS. EFS is designed to encrypt files on a Windows machine that supports NTFS. NTFS means an NTFS formatted disk partition. Some editions of Windows client OSs like Windows 10 Home Edition do not support Windows Encrypting File System. Now you can use the GUI to go into the properties of a file or a folder, go into the advanced settings, the advanced attributes, to enable encryption. But you can also manage EFS using the command line cipher tool. In our first command example, cipher /? will provide help for how to use the cipher command. It'll give syntax examples. Cipher /e is used to encrypt. Of course, you would have to specify the subject, whether it's an individual file or a folder that contains files. You could also use cipher /adduser and /cert file to add additional users that should be able to decrypt files that you have encrypted, because EFS works at the user level. It encrypts stuff for the user currently logged in. But then you need a certificate file with the public key of the user that should be able to decrypt an EFS file encrypted for you because you're logged into Windows. You could also run cipher-d to decrypt. Just like with cipher/e, cipher/d requires the subject. What's the name of the file or the folder that you would like to decrypt? Now bear in mind that if you forget your Windows user account password, that means you won't be able to sign in, which means you're going to have a problem decrypting files that you encrypted when you were signed in. Now when machines are joined to an Active Directory domain, the Active Directory domain administrator account is set as the default recovery agent. In other words, the Active Directory administrator account is very powerful. It can be used to decrypt anyone's files for any machine joined to the Active Directory domain. Then we have Microsoft BitLocker. BitLocker is designed to work with Trusted Platform Module, or a TPM chip, which is either embedded automatically on a motherboard or you can add as an add-on component. And TPM not only stores encryption and decryption keys, but it also can be used to verify startup integrity of a machine to make sure changes haven't been made by an unauthorized user, such as changing boot device orders. However, BitLocker can be configured in group policies such that it does not require TPM to work, such as to encrypt an operating system disk. So BitLocker is used to encrypt entire disk volumes, whereas EFS is designed to encrypt individual files or folders. However, with BitLocker, the disk contents are protected when the machine is not running. Once a machine is up and running and the disk volume has been decrypted, it's business as usual, meaning things like share permissions, if you have shared folders, or NTFS permissions, if they've been set, will apply to protect those files, but they're not encrypted while the machine's running and the disk volume has been decrypted. Now, in case you run into problems, or depending on how you encrypted with BitLocker, such as using a PIN or a password, if you've forgotten that, you can use a BitLocker recovery key to get to your data. The BitLocker recovery key might be required if you're booting up through alternative mechanisms. In other words, you're not booting up in Windows normally. Maybe you're booting up into repair mode or something. You would also need the BitLocker recovery key, let's say, if the operating system disk is encrypted with BitLocker. Then we have BitLocker to go for removable media. Pictured on the screen, we've gone into the BitLocker drive encryption tool on a Windows device, and you wouldn't have this, for example, on Windows 10 Home Edition. That edition doesn't support BitLocker, but Enterprise does. And of course, Windows servers do if you've installed the BitLocker component. Either way, notice in this example that for drive C, BitLocker is turned on for the operating system disk. We have a number of options on the right. We could suspend protection temporarily, back up the recovery key, or turn off BitLocker. But down below, under removable data drives, we have BitLocker to go. And so for things like removable USB thumb drives, or even large capacity USB drives for backup purposes, you might enable BitLocker to go encryption. for protection of data at rest. And you might enable that such that you have to enter in a password to decrypt it once the machine's booted up, or you might have to insert a smart card to decrypt it. Encryption is also possible using third-party tools, such as on a Linux machine. You might use OpenSSL for file encryption. So in our first command example, you could type in OpenSSL help to get help on how to use this command and its syntax. In our second example, we're using the sudo prefix command because normally OpenSSL has to be run with root privileges. If you're not logged in as root and you are an sudo configured user, you could just prefix it with sudo. So here they're specifying OpenSSL AES-256 CBC mode. They're also specifying that they want to use a random salt value, and the input file -in that needs to be encrypted is called file1.txt. -out specifies the name of the encrypted file, in this case file1.txt.encrypted. And you can specify multiple iterations to add enhanced security. Down below in our last example, OpenSSL is being used to decrypt with the lowercase d, where you specify the input file with -in that is encrypted, and then with -out you specify the name of the decrypted file that you want to result in. Finally, we can also enable encryption for cloud data at rest. So for instance, in Microsoft Azure, you might enable encryption for an entire Azure storage account in the cloud or individual items within the storage account. You might use cloud provider keys, or you might be required, let's say by regulations, to use customer managed keys that are entirely and solely under your control to encrypt data at rest in the cloud. Now in the cloud, of course, we also have network encryption available via HTTPS, as well as perhaps using a VPN encrypted tunnel to secure the connection to the cloud. In this demo, I'm going to be using Windows Server to go through some password best practices that can be applied centrally in an Active Directory domain. Now, you can control password settings, things like password length, whether a password is required, when the password expires. You can do that on a single individual machine if you want in the Windows environment. For example, here in my Windows Server, I'm going to go into a command prompt. So from the Start menu, I'll type CMD and press Enter. And from here, I could run gpedit.msc, Group Policy Editor, Microsoft Console. That would allow me to configure group policy on this individual machine. So for example, on the left under Local Computer Policy, if I drill down under Computer Configuration, Windows Settings, then down under Security Settings, then down under Account Policies, I could choose the Password Policy and many other items. Any changes made here would apply only to the local system. But what if I have an Active Directory domain, which I do? Could I not configure password settings so that it would apply to all user accounts in the Active Directory database? The answer, of course, is yes, we can do that. First, here in the Start menu on my server, I'm at a domain controller. I'm going to go under Windows Administrative Tools and choose Active Directory Users and Computers. So I have an Active Directory domain called quick24x7.local, and I've got a number of users, such as under the HQ headquarters, users like Jen Hill, user1. Under Eastern Region, if I drill down under its users, OU, I've got Max Bishop. So I've got a number of user accounts, not to mention the built-in user accounts, like under the users container, the administrator account, the guest account. Okay, you've got a lot of users is the point. I would like to configure password settings that would apply to all of the users in the domain. And so I don't do that from within here, within Active Directory Users and Computers, so I'll shut that tool down. From the Start menu, I'm going to open up Windows Administrative Tools once again, except this time down in the G's, I want to choose Group Policy Management. Now that takes me into Group Policy Management for my Active Directory domain. Any organizational units or OUs will be shown here because you can create a group policy object, a GPO, and configure a bunch of group policy settings, and you can link or associate that GPO, which I've selected here, to an OU. And the settings would only apply to users and computers in and under that OU. But you might say, well, wait a minute. Where's the default users container where the administrator account lives in Active Directory? Because let's pop up the Active Directory users and computers tool again. There's the users container, system container, lost and found keys. None of those, however, show up here. And that's because you cannot assign GPOs directly to a container. You can to an OU. So why show containers if you can't apply group policy to them? That's why they're not shown here. Okay, excellent, no problem. Now you can create a GPO by right-clicking on an OU and create one and link it to that location. And you could even go to a different OU and right-click and link an existing GPO. So you could have a single group policy object, a single GPO that you use many times to link to different OUs. However, here's what you have to be careful of. If you look at a GPO, so I've got a group policy object here for my headquarters OU. I'm going to right-click on it and choose Edit. That opens up the Group Policy Management Editor where all of the settings, of which there are thousands, are exposed. For example, under Computer Configuration on the left, under Policies, Windows Settings, Security, Account Policies on the left, and then Password Policy. This is familiar. We looked at it in GP Edit just for the local machine. The difference here is it looks like it would be for the HQ OU because this GPO is linked underneath the HQ OU. Here's the thing. The password settings options will not work at this level. They only work at the domain level. So in the default domain policy GPO, which is indented under and linked to the domain, that's where you would make those settings. If I right-click on it and choose Edit and really go through the same thing. So on the left, under Computer Configuration, drill down under Policies, Windows Settings, and again under Security, same thing, and then go under Account Policies and Password Policy. This is where you want to make these changes. So for example, maybe the minimum password length in our environment needs to be 10 characters. Okay. And password complexity requirements are enabled. So we have a mixture of upper and lowercase letters. The minimum password age, I'm going to bump that up to 10 days. That's how much time must go by before users can change their password. I don't want people changing their password over and over and over until they can get to the point and reuse the same old password, which, by the way, we can limit as well with the enforced password history option. It's remembering the last 24 passwords for users so they can't keep reusing the same password. Of course, the maximum password age here, let's say our company security policies state that passwords must be changed every 60 days. So I'll change the maximum password age setting then to be every 60 days. That now is what will be in effect for users in the Active Directory domain. It might take some time for group policy to be put into effect for computers joined to the domain, but I could force that from the command line, even directly at the server itself where I've made that change by running gpupdate/force. Otherwise, it could take 90 minutes, maybe even a few hours, depending on your wide area network topology. So once that's done, if I were to go into the local gpedit.msc and check out to see if the settings are applied from group policy in the domain, so if I go into computer configurations, again, same old thing, Windows settings, security, account, password, it did set the maximum password age to 60 days. Minimum password length is now 10 characters. So it did read those settings from the centralized group policy password settings. Securing IT computing environments means making sure that end users are aware of best practices. Not only do we want to have a safe working environment, whether people are working from home or in an office building or out in the field, but we also want to make sure that people are aware of safe computing practices. So the first thing to think about with end users is periodic refresher training. Now, there might be training that's provided to people for new operating system rollouts, maybe, for example, rolling out Windows 11 compared to Windows 10, or maybe on the use of cloud computing. Maybe that would apply at the technician level. But end users should always be trained even on changes in the interface for a piece of software to make them as efficient as possible. Maybe being trained on the newest application software that's being used, whether it's Microsoft Office or LibreOffice, or it could be any type of tool. And also on how to use things like VPN connections, maybe when working remotely from home or working away from the office traveling. We can't just expect the average end user to be able to know what to do 100% of the time. They really should be trained properly. The other thing is that we have to be careful about how the training is delivered, whether in person or remotely. The last thing you want to do is provide people a document to read to do their own training. You need to engage people. We've all probably attended courses where the trainer is very dull and speaks in a monotone voice. Nobody wants to hear that. It needs to be real, it needs to be personal and relevant. And so that is always going to be important. Choosing the correct presenter goes a long way in ensuring people retain and enjoy the learning experience. And remember, when it comes to IT security, really, the weakest link is the human element. People need to be aware of security issues. The average end user needs to resist the temptation to write down complex passwords or usernames and stick it on the monitor or the back of the monitor or under the keyboard. Definitely not a good security practice. Wouldn't take much for somebody else in the office or the cleaning staff at night to see that information. The other thing is telling people usernames or passwords, not even just in the corporate world, think at a personal level. Do you really want to tell people your bank account number or your password for online banking or the PIN to use your credit card? When you do that, you are running a risk. Another example of an end user best practice for secure computing would be to never save credentials when prompted. You might have a web browser whereby after you sign into a website for the first time, it asks you if you want to save your credentials. That really depends on how the web browser is configured. Maybe it won't prompt you, but you don't want to do it. The same thing goes with any apps, whether we're talking about on a desktop or on a smartphone. Yes, it's very convenient to have your banking app remember your credentials, because you might go under the logic that, well, my smartphone uses facial recognition and only I can unlock my phone and then run that app where I've saved my credentials. But what if there's malware on the machine? If you have a machine infected with malware, it's possible that malware would be able to sign in as you on all apps where you've saved your credentials, including online banking. Security is always inconvenient. You have to weigh the costs and the benefits to determine, is it worth the hassle of entering in credentials every time I want to do something like online banking? Or it might not be your choice. You might have to follow organizational security policies. Another best practice, always attend any offered security training. Some organizations might require it. It might be mandatory. Maybe attendance will be taken, whether online or in person, with the training. But the great thing about security training, it's a moving target. It's always changing, always evolving. Scammers are always finding new ways to take advantage of the latest technological change. So people need to be made aware of scams, current scams, phishing emails. Phishing emails are those email messages that look legitimate. And as an example, it might be something like, oh, click here to claim your income tax refund. Or it might be a message about your long-lost cousin that left you $10 million. You just have to send over $2,000 overseas to release the $10 million. We have to resist the temptation to believe these things. Also, you might get suspicious impersonation phone calls through a telephone, where someone might state that they are part of law enforcement and that criminal activity was detected on your computer, and unless you pay a fine, you could face imprisonment. So really, a lot of scammers will try to appeal to people's greed for free money or people's fear of law enforcement or the tax department, that type of thing. Having periodic training refresh sessions on these types of things will go an enormously long way to help safeguard private data within the organization or even personally. To this day, a very effective phishing scam is simply to send someone an email that looks legitimate and tricking them into clicking a link that infects their computer. That is still effective today, despite the fact that, at least in the IT security world, this has been well known for a very long time. Still happens all the time. Other examples of end user best practices: using lockdown cables to protect expensive items that have value, like high-end laptops or projectors, or making sure that employees understand they should lock computing devices in a vehicle trunk if they're going to be leaving it in the vehicle unattended, assuming the temperature is not too cold, as opposed to leaving it on the front seat or the back seat where it's visible and could tempt someone to break into the vehicle to steal it. Another best practice, do not plug personal USB thumb drives into work computers because you might have an infection on the thumb drive, and if AutoRun is enabled on the work computer, it might automatically infect the computer. Of course, we can always make sure that we have the latest and up-to-date virus scanners. Ideally, the IT team will have blocked the use of external USB media and maybe disabled AutoRun. All of these things can be mitigated. End users should also be educated to the fact that they should never post work-related pictures, documents, addresses, or anything related to work on social media. Everyone in the organization should be aware of relevant incident response plans or IRPs that could affect them, such as disconnecting infected computers from the network when an infection is detected. Also, an awareness of relevant disaster recovery plans or DRPs, which apply after a negative incident has occurred. For example, contacting the help desk if you've got important files that were deleted, whether intentionally or by mistake, or files that have become corrupted, but you need those files. Continuing on, the list goes on and on and on for best practices. Keep security cards like smart cards or PKI cards or building access proximity cards. Keep them in a secured location so not anyone can get their hands on them. It's even possible in some cases to copy proximity cards to gain access to a building. If one of these cards is stolen, then potentially someone could use it. There are times when that's not the case, like with the smart card that also requires knowledge of a PIN. And finally, people should always report suspicious persons or report strange computer behavior or notify the IT security team when there is a phishing email message that appears to have come into their mailbox. In this demonstration, we're going to take a look at some account management fundamentals, both in Windows as well as in Linux. Let's start in Windows, specifically with an Active Directory user account. So I'm at a server that is joined to an Active Directory domain. So from its Start menu, I'm going to go under Windows Administrative Tools, and I'll choose Active Directory Users and Computers. What I want to do is create a new user account, but then configure things like login time restrictions and some password-related options. So to get started here in Active Directory Users and Computers, I've already got an OU, an organizational unit that I've created previously called Eastern Region. And under that, I created a sub-OU called Users to organize user accounts. I have one user here, Max Bishop, but I'm going to create a new user. So I'm going to right-click on the Users OU. I'll choose New, and I will choose User. I'm going to create user Jonathan Gold, or user logon name of J Gold. It will add as a suffix after the @ sign the DNS domain name of my Active Directory domain. I'll choose Next. And I'll specify and confirm an initial password for this new user account. It's set so that the user must change the password at next logon to something that they know. I'll leave that on. And that's all I'll do here. I will click Next and Finish. Now that's how we manually create an Active Directory user account, which can be logged in to using any machine joined to the domain. Now in many larger enterprises, there might be a human resources tool whereby as part of the user onboarding, when you create a new user, it automatically does this in the background. Or you might have a script perhaps that uses PowerShell commandlets that does it. There are many ways user accounts can be created. If I go into the properties of user Jonathan Gold by double-clicking, under the Account tab, one of the options is Logon Hours. According to the legend, a colored in blue block means logon is permitted. But if it were white, it would mean logon is denied. So if I don't want this user signing in at all on Sunday, I could select all of the time frames on Sunday and choose logon denied, and now it turns all white. Same things on Saturday if I don't want them using that account to sign in then, or perhaps even after hours. Maybe we'll say after 6 or 7 or whatever the case is that is applicable, deny logon. So we could do that as well as part of the configuration for user accounts. Now, if I were to go into the Start menu here on my domain controller, and in the G's, if I were to go down to Group Policy Management, I could even go into the Default Domain Policy GPO, so I'm going to right-click on it, which applies to all users and computers in the domain. I could edit it, and if I were to drill down under Computer Configuration, Policies, Windows Settings, Security Settings, then I could go into Account Policies, even the Account Lockout Policy. So what I might do is say, look, after, let's say, 3 incorrect login attempts, I want the account to be locked out, and I'll accept the defaults for up to 30 minutes. After 30 minutes, this timer is reset, and people can try to log on again. Or if they contact the help desk could remove the lock in the account prior to the 30 minutes having elapsed. This is a great way to help thwart brute force attacks against user accounts, password attacks. Now let's take a moment to look at creating users and groups in a Linux environment. Now, depending on the distribution of Linux you're running, you might have a different graphical interface with different tools to create and manage users and groups. We're going to do it strictly from the command line. So I'm going to start by adding a group. Now, because I'm not logged in as root, if I run who am I, I'm logged in as a user called C. Blackwell. So because I'm not logged in as root, and I'm going to be creating user accounts, which requires elevated privileges, I will have to prefix my commands with sudo. So sudo, let's say I want to use group add to add a group, and I'm going to add a group here called group1. It asks me for the password for my current logged in user account. Well, I should know that because that's who I'm logged in as. So I'll go ahead and enter that. Now that that's done, the group is created. That's how quick it is. If we clear the screen with clear, I can run the tail command to view the last few lines of a text file. And the text file I'm interested in exists within /etc, and it's called group. When I do that, notice group 1 is shown at the very bottom of the list. Okay, so the group was successfully created. Now what I want to do is I want to add a user account and make sure that we add them to group 1. So to do that, I'm going to run sudo. Now previously we used group add to add a group. As you might guess, we would now use user add to add a user account. I'm going to add a user account here for J. Hill. I'm also going to specify -m, case sensitivity is important here, because I want to create a subdirectory for user J. Hill, and then I'm going to use -g to add that user to a group called group 1. I also want to set a password for user J. Hill, so sudo passwd J. Hill, and I'll set and confirm a password for that new account. Okay, so now that that's done, if I were to run, let's say, sudo tail /etc password, spelled passwd, password file contains user account information, such as jhill, and the fact that there is a home directory for that user, the default logon shell when they log on. And also, notice that we've got an ID for the user, 1003, but then there's a second ID here of 1004. Well, if we use our up arrow key to go back and tail the group file, notice that group 1 has an ID of 1004. That's how the user is associated with the group. So that gives us a sense then of how we could manually create users and groups here in the Linux subsystem. So this gives us an idea then of how we might use the command line to create users and groups in Linux. In larger enterprises, there's usually some kind of human resources automated system that might use an underlying runbook that does this in the background once you start filling in information about a newly hired employee. Let's take a few minutes to talk about administrative type user accounts. We're going to start in Linux, and then we'll go into Windows. So here in Ubuntu Linux, I'm logged in as a regular user by the name of C. Blackwell. So if I run who am I, it verifies this. I'm not logged in with the Linux super account by the name of root. I can switch to that account using su space dash. Su in Linux means switch user. The dash means I want to run the entire environment as if I did a full-fledged logon for that user. Now, you don't have to specify root because it's implied if you don't specify a name here. So I'm going to go ahead and press enter, at which point it asks for the password for the root account. Now, if I don't know the password for the root account, or it's because I've forgotten it, perhaps it's a Linux distribution where by default there was a root account password set, but it's not documented, one consideration, you might be able to use the sudo command prefix to run elevated privileges, and then the password command, passwd, and specify that you want to reset the password for root. So I'll go ahead and confirm the new password I'm setting for the Linux root account. And it says password updated successfully because my current logged on user, C. Blackwell, is allowed to use the sudo command. So using the up arrow key, let's do the su dash thing again. And this time I'll enter in what I know to be the password for the Linux root account, and I'm in. I'm now logged in as the root account. Now, you shouldn't be logged in with a super powerful account all of the time because you run the risk of doing a lot of damage to the system mistakenly. So I can just type exit to get out of that login session, and I'm back in as C. Blackwell. In Linux, you can use the userdel command to delete a user account. This is going to vary from one distribution of Unix or Linux to another. In some cases, you can delete user root. Other cases, you cannot. Bear in mind, if I run sudo tail /etc password passwd, then the root account information. Now, bear in mind that you may or may not be able to delete the root account. It really depends on the Unix or Linux distribution. But the question I would ask is, why are you trying to do that? You should not remove that account because it has full permissions to do everything on the system. What should be done is applying a very complex password for that root account. Now let's talk about the Windows Administrator account. Here in Windows 10, I'm going to go to my Start menu and search for the word Computer, and I'm going to spawn the Computer Management app. Because in here, I can go on the left under Local Users and Groups and choose Users. Here we have the built-in Administrator account. It's kind of the equivalent of the Linux root account in that it has full unfettered access to everything on this machine. Normally, this is disabled by default in Windows 10. If I double-click on the Administrator account is disabled, it does not have a check mark. With the default Windows 10 installation, the Administrator account is disabled, so it can't be logged in with. However, if we remove that account or attempt to, if I select Administrator and click the X, it's asking me, are you sure you want to do that? If I choose yes, it says, well, that account's logged on right now. You still want to try to delete them? Yes. And it's telling me if you're going to delete that admin account, you better hope you have another one that has administrative access. That means having another user that's in the local administrators group for this computer. Okay. And then I get a message. It says, well, we would have loved to have done that for you, but you cannot delete a built-in account. What you can do is rename it. So if I go to Administrator and right-click, I can choose Rename and call it something Guest2. So any malicious users that can enumerate this list of user accounts on this computer probably won't try to break into Guest2 as it doesn't appear to be a powerful account. So we can rename administrative accounts. We can't delete built-in accounts like administrator, but we can also right-click and set the password to whatever we want. Ideally, just like in the Linux root account environment, the Windows Administrator account password should be very complex. In this demonstration, we're going to focus on dealing with AutoRun and AutoPlay, which are really kind of the same thing, two different terms. In Windows, for example, it can be convenient that when you insert removable media, whether it's a CD, DVD, Blu-ray, USB thumb drive, that it automatically pops up. And on the root of that drive, if there's some kind of an automated installer or if it's configured to automatically run something, it does it. But doesn't that also mean it's a security risk? It certainly does. Many organizations, for security purposes, will disable the auto-run feature in Windows. If someone wants to plug in removable media and run an installer from it, they're going to have to go do it themselves. If external media is even allowed to be inserted in the first place, that can be prevented through group policy. So here in Windows 10, I'm going to go into my Start menu and I'm going to type Auto, and here we've got AutoPlay settings. So it says use AutoPlay for all media and devices, and it's set on. So AutoPlay defaults for removable media. We can choose to take no action, to open a folder to view files in the File Explorer, or to prompt the user and ask them, or to configure storage settings. And for memory cards, such as SD cards, maybe you have a laptop with an SD card slot or a USB device that allows you to plug in SD cards from your phone or digital camera. You can choose to import photos and videos automatically or play with Windows Media Player, that type of thing. Let's see if this is correct, in that if I plug in an external USB thumb drive, what is going to happen by default? Well, it's popped up and it's asking me, select to choose what happens with removable drives. Okay, well that's in line with what we have back here. So we can have it configure storage settings or do whatever the case is. Now this is a BitLocker protected drive, so it's going to need me to enter a password before I can decrypt it and get to the contents of the drive. Point is that we can configure autoplay settings here in Windows 10. Now in this case, that drive was BitLocker encrypted and there's nothing that's automatically set to start on that device. So no harm, no foul, all good. But what if there is something that's set to autoplay on removable media? So now I've got a DVD drive. It says select to choose what happens with this disk. Open folder to view files, take no action, or run an executable program. Yikes. If we were to select that whenever we insert that device, we want to auto run something, that could be an open door for security attacks. And that's what we're trying to watch out for with the autoplay options. Now let's take a moment here on a Windows server to talk about autoplay settings in group policy. Here on my server, I'm going to go to the Start menu. I'm going to go under Windows Administrative Tools. And in the G's, I'm going to select Group Policy Management. So we can configure group policy settings centrally here in Active Directory. Any computers joined to the domain might be affected by our configured settings here. I say might. It depends how you configure your GPO, your group policy object. For example, if I look at the default domain policy, which is tied to the Active Directory domain and flows down to all OUs by default, yes, if I make changes in that GPO, yeah, it will flow down to every user and computer in the domain. Well, that's what I want for this autoplay stuff. So I'm going to right-click on the default domain policy, and I'm going to choose Edit. And that opens up the Group Policy Management Editor. So what I want to do now is look at my autoplay settings in Group Policy. So on the left down under Policies, I'm going to drill down under Administrative Templates, where I'm going to right-click on that and choose Filter Options. I'm going to turn on a keyword filter for the word autoplay, and I'll click OK. So now when I click all settings under Administrative Templates, I am only seeing settings that match my filter, which is autoplay. This is brilliant because we can do things like disable autoplay for non-volume devices or prevent autoplay from remembering user choices. We can set the default behavior, or we can actually turn it off. If I enable this option to turn it off, I can then specify whether it should be for all drives or just CD-ROM and removable media drives, which I'm going to select, and OK. Now remember, that group policy setting needs to be brought down to domain-joined computers, and that can take a matter of minutes. It might take a matter of hours, depending on your replication topology for Active Directory, but it will be put in effect in this particular case for all machines in the domain, unless otherwise configured, such as blocking the inheritance of group policy settings in subordinate OUs. Basic security settings in the Microsoft Windows OS. We did this by exploring Windows Defender antivirus and implementing firewalls for port and application security. We explored users and groups differences, administrator versus standard users, and security login options. We discussed the difference between NTFS and share permissions, as well as covering EFS file system encryption. We discussed BitLocker volume encryption and also BitLocker to go. We then covered password best practices, UEFI passwords, and administrator credentials. And we also examined end user best practices as well as account management fundamentals. And we also then got into auto run and autoplay functionality in terms of how to enable and disable those features. In our next course, we'll move on to examine common methods for securing mobile and embedded devices.